92, and 32. This is forcing you to find which angle first. B. Good. So it's forcing us to find angle B. So we set it up. Sine 16 is to 32. Sine of B is to 92. At this point, you guys should be able to fly through the idea of just cross multiplying and hitting the sine button, whatever. So we get, let's see here. I have 92 sine 16 divided by 32. If you need to get a drink because you're dying, go for it. I'm getting an angle for B at 52.42 for B. You okay with that? Okay. So what we need to do right away then is to check to see whether or not there is a second triangle that could work with this. So we check the supplement. Supplement to 52.92, or 52.42, excuse me. Is there enough degrees left over with the original given angle of C to create a second triangle?
Yes.
So therefore you have two triangles. So if that works, you just draw the second triangle. So you'll have 92. Your B prime, 127.58. 16 is still here, and 32 is still here. It gives you two separate angle measure possibilities for A. You have the A and the A prime. And then you have a little a prime here as well. Okay. That's how you tell whether or not you have a possible second triangle. It's real fast. Every time you find that second angle, check its supplement, see if there's enough angle measure left. Okay. Do you need me to continue on through the other parts? We did. So it wasn't too scary?
No.
All right, save it. Let's add to it with law of cosines, because law of cosines uses law of sines when you're done.
Are you like at one point in time?
Yeah.
Okay, good.
Okay.
This is fire.
I don't have that much time to go through cosines. That's not real difficult algebraically. It's the setup that takes a little bit of time. What's that? So law of cosines is for when law of sines doesn't work. Law of cosines will work with side angle side or side side side. That's really the only time you have to worry about law of cosines. Because if you have side angle side, you have an angle between two sides. You can't use the side opposite. It won't work. And then if you have three sides, you don't have any angles. So it won't work. Law of sines won't work. So you use law of cosines once to create the ability to use law of sines. Law of sines is generally a lot faster than apply. Okay. So here's what happens. When you have the side angle side case, find the side opposite given angle first. And then you would go to your law of sines after you get that. When you do that, you go to what would be the next largest angle, or the largest angle possible. So you bounce it off of whatever side is the largest. Okay. Law of cosines for the three sides, you want to find largest angle first. The reason that you do that is because if you find the largest angle, you could find an obtuse angle. If you find the obtuse angle, then you don't have to worry about the ambiguous case at all. But if you wind up law of sines and you find the largest angle that's acute, you still have to go through the progression of checking for the ambiguous. Okay. The ambiguous case does show up from time to time within the law of cosines. Usually, I think sometimes with the side angle side, more often than the side 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 version. Because a lot of times with that side one, you get an obtuse angle. Okay? But as you know, all you do is just bounce it to a supplement, and you can check it real quick. Okay? So let's just do a couple examples.
Wait, can you write the law of cosines down?
The formula?
Yeah.
I haven't written it out yet. I will.
We didn't.
I did it real quick yesterday, but I'm going to show you a way of because what happens is with the law of cosines, you don't have to memorize the 3 different formulas. If you just write it out in terms of which one you are working with, I'll go through the same way. Okay. So what I want to do here is I'm going to draw my picture first. Which case is this? Side angle side. Okay. It's side angles. Don't you sass me. It's side angle side. What is it forcing you to find first? Little b. So it's forcing you to find that. Everybody okay with that? So here's what law of cosines does. Law of cosines works with the angle, bless you, and the side opposite the angle. So when you write it out, your side and the angle are on the ends. The rest of it fills in. So it's going to equal a squared plus c squared minus 2ac and then cosine of angle b. Now, if you're given angle A and you're trying to find little a, you just switch the a and the b. Okay? You switch them with the a's and b's. So it would be little a squared is b squared c squared minus 2bc and so on. It looks a little bit weird. The setup of it, bless you, takes an extra second, but if you're solving for the side, it's just pressing a button. If you're solving for the angle, you have to press a couple of buttons. Okay. So in this case here, I need to solve for little b, knowing little a, little c, and big B. Fill in the blank. B squared is 12 squared plus 16 squared minus 2 times 12 times 16 times the cosine of 38. Are there any variables on the right-hand side of that equation? Nope. So, what do? Plug and chug. All you're doing is just entering it directly into the calculator. And if you type it in exactly the way that you write it, you'd be better off. Okay? 12 squared plus 16 squared minus 2 times 12 times 16 cosine 38. And it gives me some number. That number equals what? So you've got b there. How do you solve for b now? Second square root of your answer. There's b. And then you just use law of sines because now you have an angle and a side opposite.
I understand.
Good. Okay.
And we have 4 days. Good. It's a good day. That's a good day.
So if you go through the law of sines then, what angle do you think you should find next? Always try to go to the next largest angle, okay? Or what would be the larger of the two angles? Because you could wind up with an obtuse angle, you don't have to worry about anything, but if you get an acute angle, what should you check?
Do you mean the other way around?
What's that?
Wait, isn't it this obtuse?
No, I said if it's an acute one, then you'd have to check to see if it has the supplement that can make it up a second triangle. That's all. No, obtuse will always give you just one. It was the acute one. Yes, sir.
So, with law of cosines, I think I might have missed something, but like, if you're looking for little a, then you put little a squared equals b squared.
Yeah. What happens that if you're looking for little a part, it's going to be the b squared. It's going to be the other pieces. They just rotate themselves through.
Okay.
They just rotate through.
All right.
The letters
Yep,
just rotate
that
around.
makes total sense.
Okay. So
Awesome.
if you just always think about it, those two will always match.
Yes. All right.
Okay.
Thank you.
The other part is when you're working with the side-side-side case. If you're working with the side-side-side case, what you want to do is you always want to try to find the largest of the three angles first. Okay? So it's 8, 18, and 13. Little a is 8, little b is 18, little c is 13. Which of those three sides is this forcing you to find first? B. Very good. So, do the same scenario. Write it out. I know that little b squared, a squared, c squared minus 2ac cosine. Substitute in what you know. Now you're going to have a variable on the right, so you're going to have to work backwards. Bless you. Do not try to put all this in the calculator at once. You will get it wrong. Okay? What I want you to do is see that you have 18 squared, then you have this part being added together, then you're subtracting this part being multiplied together. So figure out this, this, and this, and write it down, and rewrite the problem. You okay with that? What's the difference between this equation and this? Nothing. Absolutely nothing. What would you do to the equation I just wrote below it? I'm saying, I'm looking at this one. What would I do? I would solve for x here. Yes, sir.
Wait, didn't you say to keep the, like you have to subtract the 8 squared plus 13 squared minus the 2 times 8 before you do that?
No. See the difference between, can you do that here? Can I take 5 minus 3?
No, but I thought that's what you did.
Can I do that here?
I thought that's what you do with boxes.
No. What I'm doing here is, all I'm doing with this part is this, it's 2 times 8 times 13 times the cosine of b. I'm basically figuring out what's the coefficient in front of the x. Because my unknown here is dealing with the cosine. And this is, the part of this is where it gets to be a little bit weird, because it's something times the cosine of some angle. So there's an extra piece in there. So if I'm looking at this one, I would subtract the 5, and I get 7 equals negative 3x. And I divide by negative 3. And that would be my answer. Okay?
I didn't get 12, I believe.
That's just an example.
Oh, it's just an example.
That's what I was like.
That's why I was just saying, this is just a 2-step equation. That's just a 2-step equation.
Okay.
Okay? That's all it is.
I see. Yeah. Okay.
So, because a lot of times people freak out when they see this whole cosine, this stuff with the cosine in there at first, because all you're doing is working backwards. You got to subtract the 233. and then divide by. And now you have some decimal equal to the cosine of b. What do you press on the calculator to find b? Second cosine of your answer, and hit enter, and you get an angle of.
What's that called again? Like inverse cosine or something?
Yeah, inverse cosine. Arc cosine is another way to say it too. And now you have your angle. And it's out of 2, so you don't have to worry about it.
I got a negative.
There's problem.
Can you go back to the, or the SAS one that you did for law of cosine?
Yeah. Oh. The idea here is that when you have to solve for the angle itself, it's a 2-step equation with an inverse cosine at the end. Okay? It's a 2-step equation with an inverse cosine at the end. And notice we took an inverse cosine of a negative number. That's fine, because the negative number just means that the cosine value was in the second quadrant. Second quadrant had angles between that are greater than 90 but less than 180. Do you agree on that? Cosine was our x values. Is x positive or negative in the second quadrant? It's negative. This is why these things can bounce into the second quadrant, have a negative cosine value. Now, just think about this. Would this have a positive or negative sine value for 115? Be positive. Be a positive because sine, remember, the sine is your y value. Is y positive or negative in the second quadrant? It's positive. These are these little things that we'll start to pick up on a little bit more once we get rid of these pesky calculators. We're getting it. Start from 0 and works its way up.
Yeah. Sines or
It's all basically there. Want to do one more?
No, this is. We're gonna be at like 2 minutes.
Oh, that's right.
Yeah, let's keep it on.
So let's do this then. This is 13.6. It's page something or another. I think it's 810.
What's up?
Do 18 through 23. 6 of them. Okay? Don't forget, if that second angle you find is acute, to double check to see if the ambiguous case does occur. From time to time, it does. Yeah. Always double check your second angle. Yeah, because you got to use law of sines anyway. It's always easier to use law of sines after you use law of cosines. Yes, ma'am.
Yeah.
Not a gag gift, but I like it.
It expresses the true meaning.
And you're right, Marcy. That's why it wasn't working. So it's just no triangle. It was that quick question I did the other day for you guys, where I put it up on the board, like you guys are all like, wait, and then all of a sudden, like, oh, yeah. Yep. Nope. You can't have a triangle if it doesn't work like that. Largest side, largest angle.